In late 1944, the United States Army Air Forces extended their reach across the ocean, striking deep into Japanese-held territories with fleets of bombers escorted by sleek silver fighters that came to define Allied air supremacy, the North American P-51 Mustang. It was on one of these long-range escort missions over the Philippines that fate delivered Japan an unexpected and astonishing gift. A P-51D Mustang, belonging to the 5th Air Force, had sustained engine damage after fierce aerial combat. Its pilot, Lieutenant Harold W. Howell McDonald, was separated from his squadron as his engine sputtered. Smoke curled from the exhaust stacks, and fuel pressure dropped dangerously low. With no hope of reaching friendly territory, McDonald scanned the endless expanse of ocean below until he spotted a small stretch of green, a remote Japanese-controlled island in the South Pacific, known to the locals as Ishigaki-jima. He knew capture awaited him, but the alternative was certain death. With remarkable skill, he managed to glide the crippled aircraft down, wheels barely touching the soft sand near a coastal clearing. The landing was rough, but the Mustang held together. The engine coughed to silence, and the war's most advanced fighter sat intact, gleaming under the tropical sun, now deep in enemy territory. Japanese sentries stationed nearby heard the commotion and rushed toward the site. What they found left them speechless. Before them rested a machine unlike any they had ever seen, its polished aluminum skin unmarred by the heavy rivets common to Japanese fighters, its broad laminar flow wings shaped for pure aerodynamic efficiency. The soldiers surrounded the aircraft cautiously, unsure if it concealed traps or explosives. Lieutenant McDonald was quickly taken into custody, disarmed, and escorted away. But the focus of their attention remained on the strange, beautiful Wabid that had fallen from the sky. News of the capture traveled quickly through the ranks. By evening, Japanese officers arrived to inspect the wreck. Engineers from a nearby maintenance detachment carefully documented the find. They noted its elegant lines, retractable tailwheel, and bubble canopy that offered an almost unobstructed 360-degree view. Even to the untrained eye, the Mustang was a marvel of modern design. The Japanese troops had captured enemy planes before, P-40s, P-25s, and even a few battered Corsairs, but none had ever arrived in such pristine condition. This was a fully operational Mustang, nearly untouched except for a damaged radiator and a few bullet holes along the fuselage. When military intelligence officers reported the event to Tokyo, the reaction was immediate. Orders were given to secure and transport the aircraft for technical examination. For Japan's aviation command, the opportunity was beyond measure. The Mustang represented the pinnacle of Allied fighter design, a synthesis of American engineering, British engine technology, and wartime industrial perfection. To study it meant to glimpse the secrets of their enemy's air dominance. As engineers prepared to disassemble the fighter, they could not help but admire its craftsmanship. The metalwork was precise to the millimeter, its rivets flush and smooth, its internal framework light yet sturdy. Even the cockpit, filled with advanced instrumentation, seemed to come from another era. Japanese aircraft of the time, though agile, lacked such sophistication. The Mustang's design reflected not just innovation, but an industrial ecosystem capable of producing thousands of these fighters every month. On the island, the captured plane was quickly concealed under camouflage netting. At night, soldiers worked by lantern light to remove the wings, propeller, and tail assembly. The Japanese feared that American reconnaissance might notice the missing aircraft or detect unusual activity, so secrecy was absolute. The disassembly team labeled each part meticulously, using improvised wooden crates to protect sensitive components. The Rolls-Royce Merlin engine, produced under license by Packard in the United States, was handled with particular care. The engine represented the heart of the Mustang's power, capable of propelling it beyond 430 miles per hour, with a service ceiling that dwarfed most Japanese aircraft. Lieutenant McDonald was interrogated, but the Japanese gained little from him. He remained stoic and silent, knowing that his captured aircraft now lay in enemy hands. He was eventually transferred to a prisoner of war camp, while the Mustang began its long journey northward across the Pacific. Packed aboard a transport ship bound for the home islands, the aircraft was guarded like treasure. As the ship sailed toward Japan, the Imperial Army Air Service prepared a reception team. They were aware of previous Allied aircraft captures, such as a P-40 recovered in New Guinea and a B-17 that had been forced down in Burma, but none were as strategically important as this one. The Mustang was the enemy's most feared weapon in the air, a symbol of Allied technological superiority. Japan's war planners believed that by studying it, they could find ways to counter its advantages or perhaps replicate its innovations in their own fighters, such as the Nakajima Ki-80 for Heiat or Kawasaki Ki-100. By the time the ship reached Yokohama, the Mustang had already become a subject of fascination within Japan's aviation circles. Military engineers and test pilots whispered about the captured American wonder. The aircraft was transported to Tachikawa Airfield, one of Japan's premier centers for aircraft testing and evaluation. Their engineers from the Army Aeronautical Technical Research Institute awaited its arrival. As the crates were unloaded and the parts laid out in the hangar, the magnitude of what they possessed began to sink in. The Japanese technicians had seen blueprints and reconnaissance photos of the Mustang before, but to touch it, to examine its every bolt and curve, was something entirely different. It was not just a machine, it was a message from the industrial heart of America, a testament to the vast difference in resources and engineering philosophy between the two warring nations. In the coming months, this captured aircraft would be studied, repaired, and flown again, this time by Japanese hands. And when it took to the skies over Tachikawa, those who witnessed it would come to understand that the war's outcome had already been written in the skies long before. In early 1945, under the gray skies of a war-weary Japan, a convoy of trucks rumbled through the gates of the Tachikawa airfield, carrying one of the rarest prizes ever obtained by the Imperial Japanese Army Air Service. Inside the trucks, packed in wooden crates lined with straw and canvas, lay the disassembled remains of the American P-51 Mustang captured months earlier in the Pacific. Soldiers and engineers gathered as the convoy arrived, their breath visible in the cold winter air. Few among them had ever seen a P-51 before, and even fewer understood the significance of what had just arrived. The Mustang was carefully unloaded into Hangar No. 4, where Japan's top aviation engineers and mechanics from the Army Aeronautical Technical Research Institute awaited. The project was placed under the supervision of Lieutenant Colonel Masaoki Tsuruno, one of the nation's most respected test pilots and engineers, known for his work on the experimental Kyushu J-7W-1 Shinden interceptor. The task ahead was monumental: to restore an enemy aircraft with limited resources and to extract every secret hidden within its metal skin. The first phase was meticulous documentation. Engineers began by examining each piece of the aircraft and sketching detailed blueprints. Every panel, wire, and control linkage was recorded. They measured the laminar flow wings, whose smooth contour and symmetrical airfoil design baffled even the most experienced aeronautical minds. Unlike Japanese aircraft, which relied heavily on lightweight materials and emphasized maneuverability, the Mustang embodied a perfect blend of durability, aerodynamics, and power. The Japanese technicians were immediately struck by the precision of American manufacturing. Each bolt, rivet, and joint fit perfectly without the slightest variation. They realized that such uniformity could only come from an advanced industrial process using precision tools and large-scale production facilities, something Japan lacked due to wartime shortages and bombing damage. The Mustang was not simply an aircraft. It was a symbol of industrial might and logistical superiority. Restoring it, however, posed significant challenges. The aircraft's radiator and part of its oil cooling system had been damaged during the forced landing. Replacement parts were impossible to obtain, so Japanese engineers improvised using components from local aircraft. Sheets of duralumin were reshaped by hand, and cooling ducts were rebuilt using parts scavenged from a wrecked Nakajima Ki-43 Hayabusa. Every decision required creativity, as Japan's access to high-grade materials had dwindled drastically by 1945. Meanwhile, mechanics labored to repair the Packard-built Rolls-Royce Merlin engine. This V12 power plant was the crown jewel of the Mustang's design, capable of producing more than 1,400 horsepower and maintaining performance at high altitude thanks to its two-stage supercharger. When the engine was first disassembled, the Japanese mechanics were astonished by its complexity. They had never seen such precise machining or advanced metallurgy. The supercharger unit, with its intricate gearing and high-speed compressor, was unlike anything built in Japan at the time. The process of reassembly took weeks, fuel lines were replaced, control cables restrung, and the hydraulic system meticulously repaired. Japanese engineers noted the sophistication of the Mustang's hydraulic flaps of landing gear, systems that operated smoothly even after months in storage. One engineer described it in his notes as a machine that thinks like a pilot, a reference to the aircraft's remarkable responsiveness and balance. By mid-February 1945, the Mustang's fuselage gleamed once more under the lights of the Tachikawa hangar. Technicians painted the aircraft with simple Japanese markings for identification, though its American insignia was still faintly visible beneath the new paint. Despite its foreign origin, the Mustang now carried the Hinomaru, the red circle of the rising sun. It was a surreal sight, an American fighter, once the scourge of Japanese skies, reborn in the heart of Japan. As word of the restoration spread, pilots and engineers from across the Imperial Army and Navy came to Tachikawa to see it. For many, it was the first time they had seen the technology that had humiliated them over the Marianas and the Philippines. The Mustang's cockpit drew particular fascination. Japanese aircraft often used minimal instrumentation to save weight, but the P-51's panel was a marvel of functionality, featuring multiple gauges for manifold pressure, fuel mixture, coolant temperature, and a sophisticated gun sight linked to the aircraft's gyro system. It was a pilot's dream, designed for efficiency and awareness. Lieutenant Colonel Tsuruno personally oversaw the engine tests. When the Merlin engine was finally reassembled, it was rolled out of the hangar and secured to a test stand. The mechanics held their breath as fuel was pumped into the carburetors and the ignition switches were flipped. The propeller turned slowly, then faster, until the engine roared to life with a deep, throaty growl that shook the ground. The sound echoed across the airfield, unlike any engine Japan had ever produced. Its smooth yet powerful hum drew crowds of soldiers and engineers who stopped their work to listen. Some applauded as the test concluded successfully. The Mustang had come alive once again. With the restoration complete, final checks were made for the test flight. Fuel tanks were filled with precious aviation gasoline, a rare commodity in Japan's final months of the war. The control surfaces were tested repeatedly, and the landing gear cycled up and down without failure. The aircraft had become a living laboratory, a captured embodiment of everything Japan had failed to achieve in mass production and mechanical precision. The Mustang's rebirth at Tachikawa was more than a technical triumph, it was a moment of realization. The engineers and pilots knew that no amount of bravery or skill could overcome the immense gap in technology and production capacity between Japan and the United States. As they prepared for the first test flight, whispers spread among the mechanics. Some viewed the aircraft with admiration, others with quiet dread. One engineer remarked, "This machine fights with the power of a nation behind it. We are only fighting with our hands." The restored Mustang, now bearing Japanese markings but retaining its American soul, stood ready for its return to the skies. Its next journey would not be into battle, but into the hearts of those who would come to understand, through first-hand experience, why the Allies ruled the air. The coming test flights would offer revelations far greater than any technical report could convey. They would reveal the truth of industrial warfare and the destiny that awaited Japan's shrinking empire. In March 1945, the captured and restored P-51 Mustang rolled to a halt at the edge of Tachikawa airfield. Its silver fuselage gleamed under the sun, interrupted only by hastily painted red Hinomaru roundels on its wings and fuselage. Mechanics and officers gathered to watch, aware that what was about to happen was unprecedented. An American-built fighter, the symbol of Allied air supremacy, was about to take off under the control of a Japanese pilot. Every man present understood that this moment would be remembered long after the war ended. Captain Masaoki Tsuruno adjusted his flight gloves as he climbed into the cockpit. He was no ordinary pilot. Tsuruno was an aeronautical engineer and test pilot of exceptional skill, known for his experimental work on the Kyushu J-7W-1 Shinden interceptor, a forward-thinking design that, like so many Japanese projects late in the war, had come to late and into few numbers. He had spent weeks studying the Mustang, familiarizing himself with every lever, dial, and gauge. The cockpit layout impressed him deeply. Unlike the cluttered and minimalistic setups of Japanese fighters, the Mustang's controls were logically arranged, designed for both comfort and combat efficiency. It was clear that the Americans had built this aircraft not merely for flight, but for mastery in the skies. The ground crew stepped back. Tsuruno signaled for the chocks to be removed. He pressed the starter, and the Merlin engine sputtered before bursting to life with a deep, throaty growl that rolled across the airfield. The sound was mesmerizing, a low, confident hum that promised both grace and violence. As the engine warmed, Tsuruno eased the throttle forward, testing the responsiveness. The aircraft rolled smoothly, its power immediate yet controlled. Every mechanic watching could feel it. This was not just another fighter. This was the result of an industrial machine that had perfected the art of war in the air. Tsuruno lined up on the runway, released the brakes, and pushed the throttle to full. The roar of the Merlin engine grew into a thunderous symphony, propelling the aircraft forward with a force unlike anything he had experienced. The acceleration was breathtaking. In seconds, the Mustang leapt into the air, climbing with effortless grace. Observers below shielded their eyes as the silver aircraft soared upward, its silhouette cutting through the thin clouds like a blade. From the cockpit, Tsuruno felt the aircraft come alive beneath him. The controls were smooth and precise. Every movement of the stick translated instantly into motion, yet the plane remained stable. At 10,000 feet, he opened the throttle wider, and the Mustang responded with a surge of power that pressed him back into his seat. The altimeter climbed rapidly. Even at 20,000 feet, the engine showed no sign of strain. The Japanese fighters he had flown, such as the Ki-80 for Haid and the A6M0, would have struggled to maintain such performance. The Mustang, however, seemed to demand altitude. The higher it flew, the stronger it became. When Tsuruno engaged in simulated maneuvers, he discovered something even more extraordinary. The aircraft could dive at tremendous speeds without losing stability, thanks to its laminar flow wing design. The Ki-80 for N0 both suffered from structural weaknesses at high speeds, often leading to control stiffness or outright failure. The Mustang, by contrast, remained firm and responsive. He tested sharp turns, rolls, and climbs, and each movement felt as if the plane anticipated his intentions. In his flight notes, he later wrote, "The Mustang flies as though it possesses a soul. It obeys instantly, yet with intelligence." The speed tests astonished the observers on the ground. The Mustang could reach more than 430 miles per hour at altitude, a figure that eclipsed Japan's fastest operational fighters. Its climb rate, too, was unmatched. Even with a full load of fuel and ammunition, it could ascend faster than the lightweight Zero. Engineers who recorded the data realized that this combination of speed, power, and endurance explained everything: why American bombers could now reach Japan unchallenged, and why Japanese air defenses had been steadily overwhelmed. After an hour in the air, Tsuruno brought the Mustang in for landing. The aircraft descended gracefully, touching down with a precision that drew applause from the ground crew. As the engine shut down, the sound faded to silence, leaving only the wind across the airfield. The Japanese officers and engineers approached as Tsuruno stepped from the cockpit, his face calm, but his expression grave. When asked for his initial impressions, he spoke quietly. "This machine," he said, "is a generation beyond anything we possess. It is not merely faster. It is crafted with understanding of aerodynamics, of materials, of the pilot himself. It is built for war as we cannot build." His words carried a heavy truth. The men around him knew it as well. They had not just tested an enemy aircraft. They had witnessed the physical embodiment of Japan's fading hopes for aerial victory. Over the next several weeks, Tsuruno conducted multiple test flights. Each session focused on a different aspect: engine performance, climb rate, maneuverability, fuel consumption, and stability under combat conditions. The Japanese engineers collected mountains of data, comparing every measurement to their own aircraft. The results were consistent. The Mustang outperformed Japanese designs in nearly every category. Its Packard-built Merlin engine delivered unmatched power at high altitude, while its fuel efficiency allowed it to escort bombers across distances previously thought impossible. The engineers also examined the Mustang's 6.50 caliber Browning machine guns, mounted in the wings with remarkable precision. Each weapon was harmonized to fire at a single convergence point ahead of the aircraft, maximizing lethality. Japanese fighters often carried mixed armaments, combinations of machine guns and cannons, that complicated maintenance and aiming. The Mustang's standardized weaponry reflected a different philosophy: reliability, ease of production, and consistency in combat performance. Tsuruno's reports were sent to senior officials in Tokyo, who reviewed them with growing concern. The findings confirmed what many already feared: Japan's industrial capacity simply could not match that of the United States. While the imperial forces continued to produce advanced prototypes, such as the Shinden and the Ki-94, they could not manufacture them in the quantities or quality needed to make a difference. The Mustang symbolized a new era of warfare, one dominated not only by pilot skill, but by industrial efficiency and technological mastery. By the end of the tests, the once proud engineers at Tachikawa regarded the captured Mustang with mixed emotions. It was both a marvel and a mirror, reflecting back the limits of Japan's ambitions. The plane was grounded and stored under heavy guard as Allied bombing raids grew closer to Tokyo. It would never fly again in Japanese hands, but the memory of its flight lingered. Those who had seen it fly understood something deeper: that the war had shifted irreversibly. The Mustang's howl over the skies of Tachikawa was not merely the sound of an enemy engine. It was the echo of an empire's decline, and a glimpse of the industrial and technological world that would define the post-war age. By the summer of 1945, Japan's cities lay in ruins, and its airfields were scarred from relentless bombing raids. The captured P-51 Mustang, once the centerpiece of Tachikawa's testing division, now sat quietly in its hangar, its aluminum skin dulled by dust and neglect. Yet within the faded metal lay a story of revelation, a story that marked the moment Japan's engineers and pilots finally comprehended the true scale of Allied superiority in the air. The technical reports compiled from the Mustang's test flights became some of the most detailed aviation studies ever produced in wartime Japan. The engineers recorded hundreds of pages of measurements, schematics, and comparative data between the Mustang and Japan's best fighters, such as the Nakajima Ki-84 Hayate and the Kawasaki Ki-100. Each report confirmed the same humbling truth: Japan's aviation industry, despite its ingenuity and courage, had fallen irreversibly behind. The engineers noted that the Mustang's power plant, the Packard-built Rolls-Royce Merlin V1650, remained stable and efficient across altitudes that crippled Japanese engines. Its two-stage supercharger allowed it to perform seamlessly above 25,000 feet, while most Japanese fighters suffered power loss and mechanical strain beyond that point. The study concluded that Japan lacked the high-octane fuel and advanced metallurgy required to replicate such an engine. Even if they had the blueprints, they could not have mass-produced it under wartime conditions. Equally striking was the Mustang's aerodynamic refinement. The laminar flow wing design, which reduced drag and increased speed, was revolutionary to the Japanese engineers who examined it. The precise manufacturing tolerances required to achieve such a smooth surface were far beyond what Japan's wartime factories could sustain. Bombings had devastated their industrial centers, forcing production into scattered workshops where consistency was nearly impossible. The Mustang represented not only superior design, but the industrial infrastructure necessary to bring such design to life repeatedly and reliably. When Tsuruno engaged in simulated maneuvers, he discovered something even more extraordinary. The aircraft could dive at tremendous speeds without losing stability, thanks to its laminar flow wing design. The Ki-84 and Zero both suffered from structural weaknesses at high speeds, often leading to control stiffness or outright failure. The Mustang, by contrast, remained firm and responsive. He tested sharp turns, rolls, and climbs, and each movement felt as if the plane anticipated his intentions. In his flight notes, he later wrote, "The Mustang flies as though it possesses a soul. It obeys instantly, yet with intelligence." Despite these sobering realizations, Japan's engineers still attempted to learn from what they could. They took measurements of the Mustang's propeller design, its cooling systems, and the cockpit layout. Some of these lessons would later influence post-war Japanese aviation design, particularly during the Reconstruction years when Japanese engineers worked under American supervision to rebuild the nation's aeronautical industry. The Mustang's legacy thus continued long after the war ended, shaping Japan's transition into a peacetime technological power. In the final weeks before Japan's surrender, Tachikawa Airfield came under heavy attack. Allied bombers targeted industrial and testing facilities across the Kanto Plain, and Tachikawa was no exception. Fires raged through the hangars and countless aircraft were destroyed. The fate of the captured P-51 Mustang remains uncertain. Some accounts suggest it was moved to a nearby storage bunker and destroyed during the bombings, while others claim it was captured intact by advancing American forces after the war's end. Whatever its ultimate fate, the aircraft had already fulfilled its historical purpose. It had revealed to Japan's military leadership the full extent of the technological divide that had doomed their empire. When American occupation forces arrived in Japan later that year, they discovered piles of technical documents and fragments of the Mustang's testing records. The reports fascinated American intelligence officers who realized that Japan had meticulously studied one of their most advanced aircraft. Ironically, both nations had admired and learned from each other's machines. The Americans had studied captured Zeros early in the war, and now the Japanese had done the same with the Mustang near its end. These mutual studies underscored a fundamental truth of warfare: knowledge, even when obtained through defeat, can become a tool for future progress. The Mustang's capture and testing also held broader lessons for history. It showed how technology, production, and logistics could determine the fate of nations as decisively as strategy and courage. The Japanese pilots who faced the Mustang in combat had often attributed their defeats to luck or numbers, but the Tachikawa tests proved otherwise. The Mustang's superiority was no accident. It was the result of relentless engineering refinement, strategic planning, and industrial might. In the years that followed, surviving Japanese engineers who had worked on the project reflected on the experience with respect rather than bitterness. Many went on to contribute to Japan's post-war aeronautical renaissance, helping companies like Mitsubishi, Kawasaki, and Nakajima's successors transition to civilian aircraft manufacturing. The discipline, precision, and humility learned from studying the Mustang influenced Japan's later approach to technology and engineering. The captured P-51 Mustang thus became more than a relic of war. It became a silent teacher, an unintended ambassador of technological enlightenment in a time of destruction. It reminded those who studied it that power in war arises not only from bravery or tradition, but from innovation, organization, and an unwavering commitment to progress. When Japan rebuilt itself in the decades after World War II, rising from the ashes to become a leader in advanced technology, some of the men who had once stood beneath the wings of that captured Mustang looked back and recognized its influence. It had shown them the future. The very machine that once symbolized their defeat had also revealed the path toward renewal. And so, the story of the captured P-51 Mustang endures, not merely as a tale of war, but as a testament to how understanding one's enemy can illuminate the road to transformation. In its silver wings lay the hard truth of industrial warfare and the first glimmer of a nation's rebirth.